Hello, YouTube. This is Umozo3. In the previous lesson, we talked about something called a concurrent hash map, right? We studied this fourth type of dictionary, right? We've already learned about hash maps in lesson 55, hash tables in lesson 59, and linked hash maps in lesson 68. But we said there's a fourth way to have key value pairs in a dictionary, right? We're talking about a data structure where we have key value mappings, right? And we said the keys in a dictionary have to be unique, but the values don't have to be unique. So you could have two different keys in your dictionary mapping to the same value, but you couldn't have one of the keys in your dictionary mapping to two different values. And we said that you can perform an iterator on the keys or an iterator on the values, respectively, by calling mydictionary.keyset.iterator or mydictionary.values.iterator. And then we said that for a hash table, which we studied in lesson 59, and also for a concurrent hash map, which we studied in the previous lesson, lesson 69, you can also do an enumeration on the dictionary, which has the effect of parsing through the values of the dictionary. But you can only do that for a hash table or for a concurrent hash map and not for a hash map or a linked hash map. But we said in general, remember, you have to understand some of the functionality you have available to dictionaries, right? So the put method, the get method, the put all method, the size method, right? We have methods, for example, to assign values to keys, to return the value associated with a particular key, to add all the key value pairs from one dictionary into another dictionary, to return the number of key value pairs in the dictionary. So hopefully by looking at lessons 55, 59, 68, and 69, you have built up some level of understanding with hash tables. And I actually think hash tables was lesson 64, not 59. So you might want to just make that correction, but hash tables was lesson 64. Anyway, what we can do is we can review some of the things we were talking about in the previous video with concurrent hash maps, and there's going to be another technique or topic to study in this lesson, which is called pass by value. So we have hash table of type string string, city to state equals new hash table of type string string. So it creates an empty dictionary. In this case, we're going to use a hash table, which we studied in lesson 64. Okay, and then we're also going to say concurrent hash map of type string string W. So what this does is it declares a new concurrent hash map. So concurrent hash map and hash table are two of the four types of dictionaries that we studied, right? Those are two of the four available approaches that you have at your fingertips for maintaining key value pairs in a dictionary. So you declare a new concurrent hash map and then you can initialize it, and then we can add key value pairs to it. So w.put of San Francisco with California. So it assigns the value California to the key San Francisco. W.put of Albuquerque with new concatenated with Mexico. So that establishes a second key value pair in that dictionary. And then w.put of San concatenated with Diego with w.get of San Francisco. So w.get of San Francisco, well, that should be California because California is the value associated with the key San Francisco. So it assigns San Diego to the value California. So San Francisco and San Diego now have the same value, even though those are two different keys in the same dictionary. So hopefully that's clear to you. And then we have w.put of Dallas with Texas. And so if we have another dictionary and we say city to state.put of Dallas with New York, and then what we're going to do is we're going to say Boolean D equals city to state dot replace of Dallas with Texas with Ohio. So remember, we said replace of A, B, C, right? If we accept three arguments into the replace method, what it will do is it will reassociate the value associated with the first argument to be the third argument only if it had previously been the second argument. So basically what we have here is we're going to say that the Boolean is assigned to true if the value associated with Dallas is changed from Texas to Ohio. But here, what we can do is we can see that the value associated with Dallas was not Texas, right? It was New York. So the Boolean D should be false. And if we say city to state dot get of Dallas, it should still say New York rather than Ohio because this replacement was not actually done. And we studied that in a previous lesson, but let's go ahead and run the code rather than just talking about it the entire lesson, right? So you go ahead and get false because this replacement was not actually made. And if you're unclear of how this replace method with three arguments works, you could go back to the API, right? You could look at the concurrent hash map API or the hash table API or the hash map API or the linked hash map API. But the point is that there's this replace method which accepts three arguments. And so you'd have to go ahead and find that. So that would be right here. So it replaces the entry for a key only if currently mapped to a given value. So hopefully that's clear to you. So if we say system.out.println of city to state.get of Dallas, it still says New York by virtue of this line right here. So hopefully that's clear to you. But then what we can do is we can say city to state.put all of W. And so what that does is it takes all these key value pairs like the San Francisco, California and Albuquerque, New Mexico, and it's going to put it into the city to state dictionary. So it turns out that you can actually add a concurrent hash map to a hash table. You can add a linked hash map to a regular hash map. You can add a regular hash map to a concurrent hash map, right? But the point is that you can mix and match these dictionary types when you're adding key value pairs from one into another. So hopefully that's clear to you. So we say city to state dot put all of W, and then we can say system.out.println of city to state dot get of Dallas. So then if we run it again, it'll say Texas because we said basically what happened is that the city to state already has the key Dallas in it, right? Dallas was associated with New York, but then W already, it's going to feed in Dallas, Texas. And so we asked if you already have the existing key value pair, like if you already have a value associated with the key Dallas, then would it get overridden when you say city to state dot put all of W, right? And W has a Dallas key as well. And the answer is yes, so it would be overridden. So now the value associated with the key Dallas is no longer New York. It would be reassigned to Texas by virtue of putting all the key value pairs from the W concurrent hash map into the city to state hash table. So hopefully that's clear to you. And then we can think about 5 ways to iterate through the values in a dictionary, right? So there's 5 approaches that you have available if you're talking about using a hash table or a concurrent hash map, right? Because you can have an enumeration on a hash table or a concurrent hash map, but not on a hash map or a linked hash map. You'd have to use one of these other 4 approaches. But first, what you could do is you could do a for each loop through the keys, calling the get of k method each time. So you could say approach 1, and then you could say for string u in city to state dot key set system.out.println of city to state dot get of u. And so it's just going to use a for loop, and it's going to call the get method on each of the keys to return the value associated with each of those keys. And so you get New Mexico, California, Texas, and California, right? Because we said San Francisco and San Diego both have the value California, right? And then I think we also had like Albuquerque, New Mexico, and Dallas, Texas. So those are your 4 values. And you can see 2 of the values are the same. And we said that's okay. We said we can have 2 keys mapping to the same values. Hopefully that's clear to you. And then we could have approach 2. So then for this approach, what we're going to do is we're going to say for string v and city to state dot values system.out.println of v. So basically what we're going to do is we're just going to iterate through the values directly using a for loop. So this will be another approach that you have available to you. And it says approach 2, and you get the exact same output. So New Mexico, California, Texas, California. And then for approach 3, we can think about using iterators, right? So you said you can have an iterator on the keys, an iterator on the values, or for a hash table or a concurrent hash map, you can also have an enumeration on the dictionary, which has the effect of parsing through the values. So what we're going to do is we're going to set up those 3 types of quote unquote iterators, right? With one of them being an enumeration. So we could say iterator of type string, KP, like key parse, equals city to state dot key set dot iterator. An iterator of type string VP, value parse, equals city to state dot values dot iterator. An enumeration of type string EP, like element parse, equals city to state dot elements. So one approach you could say is, while true, if KP, right, if the key parse iterator has the next element, then system.out.println of city to state dot get of KP dot next. So it's kind of like this first approach where we said city to state dot get of u, but instead of just referencing each of the strings in the key set, we're going to use an iterator to parse through those keys, but we're still calling the get method to retrieve the value. And we're going to use a break statement to break out when there's no next element returned by the iterator. And so that will be approach 3. And you can see you get the exact same thing on the console: New Mexico, California, Texas, California. And for approach 4, for int k equals 0, vp dot has next. So now we're going to use the iterator on the values, and we're going to keep checking to see if the value iterator has a next element. And then this is meaningless, right? It doesn't really matter what k is, but the point is that we're using this Boolean in the for loop to determine how many times we're going to run through it. And so we would just say system.out.println of vp.next, right? What's the next element returned by the value parsing iterator, right? And you get the exact same thing printed on the console. And then for approach 5, while true, if EP, if the element parse, right, the enumeration, has more elements than system.out.println of ep.nextElement, and then continue, right? So what would this do? If you have a next element, you're just going to print the next element in the enumeration, but then you continue. So you skip the rest of the loop and you don't break out of the loop, but eventually the enumeration is not going to have more elements. So you're not going to run this code and you are going to break out of the loop. And so you get the exact same thing printed on the console again. And so it says number of elements. And so you'd have 4 key value pairs, and then we could clear all of them out. So we could say city to state.clear. And then if we say system.out.println of number of elements now, it would say city to state.size, and we get 0 because we use the clear method. It's a void method, which accepts no arguments, but it removes all key value pairs from the dictionary. And that's true for a hash map, a hash table, a linked hash map, and a concurrent hash map. So hopefully that's clear to you. And then we have a real quick review of list iterators, right? We talked about list iterators in like lesson 62 or 63 or 64, I think. But what we do is we create a vector, right? And we said that we have to import, right? So if we scroll back up to the top, remember we've said this in previous videos, but if you want to use classes from the java.util package, for example, array lists or vector or collections or hash table or queue, then you need to go ahead and import the entire package, or at least the classes from the package that you'd like to use. So I just say import java.util.concurrent, and then I'm also importing the java.util.concurrent package, right? So remember we talked about 2 classes from this package. So java.util.concurrent hash map and java.util.concurrent linked queue. We talked about those 2 types of data structures in lessons 69 and 66 respectively. So hopefully that's clear to you, but you have to go ahead and remember to import those things. And then what we're going to do is we're going to say vector of type integers equals new vector of type integer numbers equals new vector of type integer. Remember we said that a vector is like an array list. It's a data structure where the elements are referenced by index position. So we say numbers.add of 8, numbers.add of 2, numbers.add of 0, numbers.add of 3, numbers.add of 7, and then numbers.add of numbers.get of 0 plus 2. Well, numbers.get of 0 would be 8, so 8 plus 2 is 10, and that's what would be added to the end of the vector. And then we say numbers.remove of 0, and remember, if you say numbers.remove of 0, it removes the element at index position 0. It doesn't remove the integer object 0. To do that, remember, you'd have to say numbers.remove of integer.value of 0, and that would actually remove the 0. But the point is that this line of code would remove the first element. So instead of having 8203710, you would have just 203710. And so list iterator of type integer parser equals numbers.list_iterator. And then we're going to say for int s equals 0, s is less than numbers.size, s plus equals 1, parser.next. So we're just going to advance the cursor position from the beginning of the vector to the end of the vector without doing anything. We're simply just advancing the cursor one at a time until we get to the end of the vector. So hopefully you can understand visually and conceptually what's happening. And then if you call for a has next element, it would return false, right? Because we're at the end of the vector at that point. Sorry, I keep hitting right click when I'm trying to hit left click. So stack of type integer LIFO, right? Last in, first out. You have to remember that stack is a last in, first out data structure. LIFO equals new stack of type integer. While parser.hasPrevious and s equals parser.previous.int value. If s mod 2 is equal to 0, parser.set of 400. So basically what we did is we talked about list iterators, and we said basically, I think I'm actually going to do the pass by value explanation in the next video because we're kind of running out of time, but it's been a good opportunity to review some of our dictionary functionality and also list iterators. So now we can go ahead and slow down on this and think about what's going on here. So anyway, let's go back. So we have a vector of type integer, numbers equals new vector of type integer. So remember the vector is very similar to an array list. And we said vector is just a legacy data structure. It's just like an array list, but it's been around longer, okay? And so we added 5 integers to the vector and then a 6th integer based on the first one, right? We said numbers.add of numbers.get of 0 plus 2. And again, we said if you call numbers.remove of 0, this doesn't remove the integer 0. It removes the integer at the index position 0. So hopefully that's clear to you and you can understand the difference. If you had wanted to remove this 0, again, you would have to go ahead and say something like numbers.remove of integer.value of 0, right? And then your vector would go ahead and look something like this, right? It would be 2, 3, 7, 10, because you actually removed the 0 where it belonged in the vector, but that would not be the effect of this remove of 0 line. So hopefully that's clear to you. But yeah, we said list iterator of type integer parser equals numbers.list iterator. So one of the things that we can do in this video is go back and remind ourselves of some of the functionality for list iterators, right? First, we talked about regular iterators, and we said that we have this item available to us, which can check for a next element and return the next element, and also optionally remove the element that was just referred to with next, and that's called an iterator, right? We said with an enumeration, though, we have longer method names, and we don't have that opportunity to remove elements from the underlying collection like we could with a regular iterator, okay? But we said a list iterator is even stronger than a regular iterator, right? Because we said that this is an iterator for lists that allows the programmer to traverse the list in either direction. So not only can you go forwards, you can also go backwards. You can also modify the list during iteration. So not only can you remove elements from the underlying collection, but you could change their values, right? And you could also add values to the underlying collection, right? That's something you can do with a list iterator, but not with a traditional iterator. Okay, so hopefully that's clear to you, but we can go ahead and remind ourselves of some of the functionality that we have here. So for example, if we look at the set method, right? If you call set, this is an instance method that acts on a list iterator. So if you call my list iterator dot set of W, well, what it does is it just replaces the element that you just referred to with next or previous with whatever you specified for W. So let's go ahead and take a look at what's happening with that. So we're going to say list iterator of type integer parser equals numbers.list iterator, right? And we said this for loop takes the cursor position from being right before the first element in the vector to right after the last element, right? From the beginning to the end of the vector. That's what this for loop does. So that's all it does, is it advances the cursor position to the end of the vector. And so there's not going to be a next element. But then if you say stack of type integer LIFO, right? We said last in, first out. You have to think about like a stack of dinner plates where it's like the last one you insert is going to be the first one that comes out, right? Last in, first out equals new stack of type integer, but it starts empty. But we're going to say, well, parser dot has previous, right? So let's remind ourselves of the elements we have, right? We would have, we're going to take out this temporary line, but 203710. And so right now the cursor basically is at this index position, right? It's going to be after the 10. So that's where the cursor is, and there's not a next element. But what we're going to do is we're going to say, well, parser dot has previous, and s equals parser dot previous dot int value. So it's going to take the int that's wrapped by the integer, and we're going to say if that int is even, right? If the remainder when you divide it by 2 is equal to 0, then use the parser, use the list iterator to replace that element, whatever it was, whatever that even number was in the vector, with 400. And then you're going to say LIFO.push of s. So what this does is it's going to add elements to the stack as the cursor goes back towards the beginning, because you're going to keep calling parser.previous, and one at a time, the cursor is going to go back towards the beginning of the vector. But each time you do that, you're going to add that previous element to the stack, right? So it's like adding the elements to the stack in the reverse order of the way they were in the vector. But then what we're going to do is we're going to say for int p equals 0, not the case that LIFO dot is empty, right? So we said the stack class provides an instance method called empty. The empty method checks to see whether a stack is empty, but we also said stack is a subclass of vector. So any methods that vector gets, stack also gets. And vector has a method called isEmpty, and we can use the superclasses isEmpty method or just the regular empty method. But the point is that you could use either one. So for int p equals 0, not the case that LIFO, our stack, dot is empty, right? It's not going to be empty because we just pushed elements onto it from the list iterator that was going through the vector, right? But while it's not the case that the stack is empty and p plus equals 1, system.out.println of LIFO.pop. So you're going to pop off the top, and you're going to read the vector from the beginning to the end, right? Because we said the way that we added elements to the stack was the opposite of the way they were in the vector. But the stack also has that sort of opposite dynamic to it too, right? So if we add the elements into the stack from end to the beginning, but then we pop them off at the top, then that has the effect of actually reading the vector from beginning to end. So then what we're going to do is we're going to get 2, 0, 3, 7, 10. And that's what we had up here, right? 2, 0, 3, 7, 10, because the stack was sort of backwards. The way that we added elements, we did it in reverse, but then we popped them back off in order. So we get 2, 0, 3, 7, 10, right? And then if we say numbers dot is empty, that would be false, right? The vector is not empty, but the stack would be empty, right? Because we called LIFO.pop. So as we're returning those elements from the stack, we're also removing them from the stack, right? And then if we say system.out.println of numbers, this will be the toString representation of the vector, right? So you can look at the toString method from the vector class, and you can see all of the even numbers in the vector were replaced with 400 by virtue of using the set method from the list iterator class. So hopefully that's clear to you, and we'll talk about pass by value in the next lesson. From UMOS 03, thanks for watching, and please subscribe.